And then we have an I can statement. So when you fold it over, this flap actually comes first. I can set up and solve consecutive integer word problems from context. But here's really what I wanted to show you. I wanted to show you that consecutive integers are one number apart. That's why we use the variable n plus 1, n plus 2, n plus 3, 4, so on and so forth, right? That's kind of how you set them up, or x, or whatever variable you choose. Consecutive odd and even are two numbers apart. So we start off with x, and then we do x plus 2, x plus 4, x plus 6, and so on. We're counting by twos, okay? So that's how you're going to set those up. So I think that we have 3 examples, 3 word problems. But before we do that, I wanted to kind of tweak your brain a little bit and have you think of some consecutive integers that fit this. Because sometimes when we think about consecutive integers, we forget that they can be negative, okay? So I want you to list 5 consecutive integers that are less than 0. Yeah, less than 0 means negative. So we always start with the smaller number first, and they're consecutive in a row. So let's start with negative 10. And then what's the next one? We're getting closer to 0. We're just consecutive, not even or odd, just consecutive in a row. So negative 9, negative 8, negative 7, and negative 6. So if we were to identify these, we would call it x, x plus 1, x plus 2, x plus 3, and x plus 4. Remember that you can have negative numbers, right? So I just want you to kind of think about this. This is always the ones, whenever you guys get negatives, it's the ones that like really trip you up. What about listing 5 consecutive integers that are less than 1? Less than 1. What's a number that's less than 1? Okay. So what if I started with negative 4? What would the next one be? And the next one? And the next one? And the last one? Perfect. So again, how are we going to identify our variables?
X plus 1, and x plus 2, and x plus 3.
And the last one?
X plus 4.
Let's see if that makes sense. If x is negative 4, what is negative 4 plus 4? Yeah, it does make sense. Okay. Last one, 5 consecutive odd integers that are less than 1. So they've got to be odd. So if we start at negative 5, what's the next one going to be? Negative 3. And the next one? And the next one? It's going to be 1. We don't have 5 of them in a row, so we can't use that. So it just means we need a smaller negative number. Negative 9. Yeah, I think that'll work. Negative 9, negative 7, negative 5, negative 3, and negative 1. So how are our variables going to be identified?
X, and then x plus 2.
Good job, x plus 2.
And x plus 3.
What do I do to negative 9 to make it equal negative 5?
So x plus 4.
Plus 4, yes. We're just counting by twos. So what's the next number? Like when you count by twos, 2, 4,
6.
x plus 6. And the last one?
8.
X plus 8. Let's check it. If negative 9 plus 8, does that equal negative 1? Yeah? Yeah. Okay, so we've identified them the right way. This is my first one, and if I add 8 to it, I get the answer that I'm looking for. Okay? All right, so that's just kind of a help you think about negatives, because You did exactly what I wanted you to do. You tried subtracting them first. And that's what I want you to think about. You're still adding. Okay, perfect. Okay, so our first example, we just have to find 3 consecutive integers. So first thing I'm going to do is define my variables. First, second, and third. I always do this first before I do anything else. They're consecutive integers like 1, 2, and 3. So if the first one is x, ask yourself, what do you do to the number 1 to make it equal 2? X plus 1. Good job, you guys. And what do you do to the number 1 to make it equal 3? Good job. Perfect. So 3 consecutive integers such that their sum is 51. What does that mean I'm going to do? What does sum mean? Add them up, set it equal to 51. So what is my first integer? X plus, what is my second integer? What is it? What is my second integer? X plus 1. That's okay. And my last integer? X plus 2 equals 51. Alrighty, let's combine some like terms. Tyler, what is x plus x plus x? Perfect. Lysandro, what's plus 1 and plus 2? Positive 1 and positive 2? Perfect. Equals 51. Michelle, what's the first step I need to do to get x all by itself? What's the first step? Perfect. Minus 3. Good job, Michelle. So 3x equals, let's see, 51 take away 3 is 48. Thank you, Lysandro. Yaritza, do you know the last step? 3x equals 48. How do I get x all by itself? Divide. Yeah, we're going to divide by 3. So x equals 16. So once you find x, once you find that first integer, remember you're looking for 3 integers. So your first one is 16. What's the next one? What's 16 plus 1? 17. And x plus 2 or 16 plus 2 is 18. Yeah, so my 3 integers are 16, 17, and 18. Outstanding, ladies and gentlemen. Okay. Daniel, example number 2. We have 2 consecutive even numbers. So we have 2 integers, first and second. Okay. So what's my first one going to be? I'm talking about even numbers. Yep. And what's the second one going to be? Good job, x plus 2. Perfect. Says such that the sum of the smaller number and twice the greater. So I'm adding up. I'm taking the small number or the small integer, which is the first, and I'm adding it to 2 times the larger, which is the second. And it has to equal 100. So Ken, can you write the algebraic equation for us? What is the first integer? Okay. Plus 2 times the quantity, x plus 2. Do you see that, Ken? Because it's 2 times the larger, so we have to put a 2 out in front of it. Are you okay with that? Equals 100. Okay. Isaac, do you feel like you can walk us through the first step to simplify? Yeah. What do I have to do with my parenthesis first? Distribute. Good job. So we have to distribute that 2 through. So 2 times x is 2x. 2 times 2 is 4 equals 100. So let's see. Avery, can I combine like terms on the left? Do you see anything that I can add together? Yeah, the x and the 2x. So remember this x has a 1 in front of it. I don't write it because I'm generally lazy. What is 1x plus 2x? 3x. Good job. So 3x plus 4 equals 100. Victoria, if you were solving this, what is the first thing that you would do? Yeah, we would subtract 4 from both sides. We would subtract 4 from both sides. So 3x equals 96. Last step, Aiden, what would you do? Divide by 3. Good job. Divide by 3. So x equals 32. Good job. So if x equals 32, that's my first integer. What is my second integer? 34. Good job. We're not multiplying, we're adding. Good, 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 good. 34. Last example. Last example. 3 sisters have ages that are consecutive odd integers. So that's like maybe 3, 5, and 7, right? Those are odd ages. So let's define our variables. First, second, and third. Okay. Owen, do you feel like you can identify all 3 variables? No? Okay. Kenna, you think you got them? If our first one always starts off as x, what do I do to the 3 to get it to a 5? Perfect. Yeah. Awesome. You guys got this. You're doing really well. Okay. It says we've got 3 sisters. Their ages are odd consecutive integers. Find the ages if the sum of the youngest and 3 times the oldest. So I'm going to take the youngest plus 3 times the oldest is, that means equals, 5 less than 5 times the middle. So 5 times the middle minus 5. So what integer represents the youngest child? What integer is representing the youngest child? X. Good job. It's the first one. Plus 3 times the, what integer expression is representing the oldest? Good job, Isaac. X plus 4 equals 5 times the, what integer expression is representing the middle child? Excellent. Minus 5. Whew. We got some distribution on both sides. Then we're going to have to combine like terms. Awesome. Okay, I'm going to draw some arrows. Ken, I'm going to have you walk us through the green arrows, like the distribution on the right side or the left side, if you would. And then Kylie, you feel like you can walk us through the distribution on the right side? The purple arrows. You got it, girl. You want me to have Tyler help us? Okay. Ken, we're ready for you. What do you want to do on the right side or on the left side? X plus what? 3x. Good job. Plus 3 times. This is multiply. 12. Good job. Equals. All right, Kylie, you're up. 5 times x is? Yeah. Plus. Awesome. Okay. Okay, so Brianne, you're going to simplify the left side. And Victoria, you're going to simplify the right side. So what do you want the left side to look like, ma'am? We're combining like terms. 1x plus 3x is 4x. So I have 4x plus 12 equals, Victoria, this is the only thing that you can combine together. What happens to that? That 10 is positive. You maybe can't see it because I drew right through it. Do you see that 10 is positive? So a positive 10 and a negative 5 are still going to give me a positive 5. Yep. Okay. So, Lissandro, do you want to move the 4x or do you want to move the 5x? Tell me what you want the next step to be. Okay. So that's a positive 4x. That means I have to subtract it on both sides. Yes. Good job. So 12 equals 1x plus 5. 12 equals 1x plus 5. I'm going to arrow over in that little workspace. Okay, Miss Ariana, what do you want to do next?
Subtract 5 on both sides.
Yeah, we're going to subtract the 5 on both sides. So 12 minus 5 is 8. Are you sure?
No.
You're right. No, it's 7.
7?
Yeah. 7 equals 1x. Don't just agree with me. I'm crazy sometimes. I make mistakes. So x is 7. So if the youngest child is 7, what's the middle child's age?
9.
Perfect. And the oldest child? 11. Outstanding. So I want you guys to get that glued into your journal.